Hi everyone. Now we are going to see the about magnitude comparator. Magnitude comparator is a one of the combination logic circuit. It is used to compare two binary values. There are three outputs from the magnitude comparators. One is a greater than b, a less than b, and then a equal to b. Only one output is high based on the input combination. If both the input values are equal, then A equal to B will be high. If A is greater than B, then A greater than B will be equal to 1. If A is less than B, then A less than B will be equal to 1. So in magnitude comparator, we are going to compare two binary values. So based on the binary values, the output will be generated. Here, there are two types of magnitude comparator. First one is 1-bit magnitude comparator, then 2-bit magnitude comparator. In 1-bit magnitude comparator, it compares the two single-bit binary values. For example, it compares the values of A and B. So, based on the values of A and B, it selects the output as A less than B, A equal to B, then A greater than B. In the case of first thing, the values of A and B are 0, 0. So, the A equal to B will be high. Remaining all are zeros. In the second case, A equal to 1, B equal to 0. In this case, A is greater than B. So, A greater than B will be equal to 1 and the remaining values are 0. Next case, A equal to 0, B equal to 1. In this case, A is less than B. So, A less than B equal to 1. Then remaining all are zeros. In the other case, the value of A and B are 1, 1. So, both the values are equal. So, in this case, A equal to B is 1. Remaining all values are zeros. So based on the input combination values, here it selects the output as A equal to B, A less than B or A greater than B. So this is a single bit magnitude comparator. Here we are comparing a single bit value of A and single bit value of B. So based on this, we are going to put the K-map. After the simplification of K-map, we are going to draw the logic diagram. In the logic diagram, we are used XNOR gate. Why we are using the XNOR gate means if both the values are same. In the XNOR gate, the truth table is if both the values are same, then the output is high. So if P equal to Q means then we are going to use XNOR gate. In the case of P, if P is greater than Q, means we are going to use AND gate. So we are going to connect the P with 1, P Q bar. Here the P is high. So we are going to connect with P Q bar. In the case of P less than Q, in this case, we are going to connect with P bar Q. So Q is high. So Q equal to 1, then P bar. So P bar is equal to 0. So we are going to connect P for P less than Q. The Q is the higher number. So we are going to connect the Q equal to 1. And the remaining is connected to the P bar. So for these three cases, we are going to connect the AND gate based on the values of P and Q. So this is the logic diagram for single bit magnitude comparator. Next, 2-bit magnitude comparator. In 2-bit magnitude comparator, we are going to compare two binary values A1, A0, B1, B0. In this case, we are going to compare the first MSB bits. If the MSB bits are compared with the MSBs compared, they have the greater significance. If in this case, if A equal to 1, 0, B equal to 0, 1. In this case, the A value is higher because here the 1, here the 0. So A is greater than B. So based on this comparison, we are going to select the outputs as A equal to B, A less than B and A greater than B. So based on this connection input combinations, we are going to get the output as three outputs. In the next case, this is the step. We are going to compare the A1 and B1. If A1 is greater than B, then A greater than B is the output. If A1 is less than B1, then A less than B is the output. Step 2. If A1 and B1 are equal, in this case, we are going to compare A0 and B0. In this example, A equal to 1, 0, B equal to 1, 1. In this case, the MSB bits are equal. So, we are going to compare with the LSB bits. So, LSB bits are A0 and B0. If you are going to compare with the LSB bits, here A0 is 0, B0 is 1. So, comparing with this bit, A is less than B. So, if MSB bits are equal, we are going to have the LSB bits. So, A is less than B. So, this is the principle for the comparison of 2-bit magnitude comparator. This is the truth table for 2-bit magnitude comparator. We are going to compare the values of A1 and A0, B1 and B0. So, based on this comparison, if A is greater than B means the corresponding bits will be high. If A equal to B means the corresponding bits are the high for the A equal to B condition. Then if A is less than B means the corresponding bits are high for this combinations. So based on this comparison, we are going to get the output as A greater than B, A equal to B, then A less than B. This is the comparison of 2-bit magnitude comparator. Then K-map simplification for 2-bit magnitude comparator. We are going to compare the values. So for K-map for less than, then K-map for equal, then K-map for greater than. So we are going to put the values in the K-map and the simplified expressions are given in the diagram. So this is the 2-bit magnitude comparator logic diagram. Here we have compared the values of A1, A0, B1, B0 and the corresponding outputs are drawn by using the logic gates. So based on the previous expression, we have drawn this logic diagram, circuit diagram for the 2-bit magnitude comparator. So in single bit magnitude comparator, we are going to compare only the single bit values. But in 2-bit magnitude comparator, we are going to compare the values of MSB first. If the MSB bits are equal, then we are going to the LSB bits. So based on these values, we are going to draw the K-map and we have drawn the circuit diagram for the 2-bit magnitude comparator. Then applications, where we are going to use these comparators. We are going to use the comparators in CPUs and microcontrollers and in all control applications where the binary numbers such as temperatures, positions are compared to the reference values. And also it is used to control the process controllers for servo motors and also used in the password verification and biometric applications. In all the central processing units and microcontroller units where we are going to compare a value with the reference value, these comparators are used. So these comparators plays a vital role in all these applications. So the comparators are the very important circuit in the combinational circuits. Thank you. As a summary of this today's class, we have discussed about what is comparator, what are types of comparators. There are two types of comparators, single bit comparator, then 2-bit magnitude comparators. So, their logic diagram, then truth table, then circuit diagram for these comparators. Thank you.